I can imagine that you know how to add, subtract, multiply, and divide numbers. Or you're used to use a calculator to do this type of computings. But the question is, do you know that the operations have inside of them information of our numbers? Let's see how rational numbers come from the operations. Okay, so I want that you ask yourself if you know how to count. I hope that you know how to count. So just remember that when you start your life in math, you start counting like things, and then you notice that you have some numbers that you used to count. Okay, let's say that these are the counting numbers. These counting numbers are the numbers that we represent in the natural number set. So, to sum up, you just need to know that the numbers that we use to count are the counting numbers. But there's a problem with the counting numbers. You can add the counting numbers easily, but we have a problem when we start subtracting counting numbers. And what is the problem? The problem is that if you subtract a number, that is, if you subtract two counting numbers and one is greater than the other, you can have an answer in the natural numbers set. But what happens if you subtract two equal numbers? We don't have an answer in the natural number set because we have to include the zero. And that is when we have the whole numbers. The whole numbers includes the zero, because in some operations it's important to have zero because sometimes we need to subtract equal numbers. For example, let's say that you ask somebody for you receive some money from somebody and you want to pay him back. So if you pay the same amount of money, you need to have the zero as a way to know that you're break even. Okay? But now there is another problem with the subtraction. And the other problem with the subtraction is what happens if we subtract a number that is less than another. The problem is that we don't have a number to express the subtraction in the whole number system or the natural number system. Let's give you an example. If you go to a bank and ask for money, you're gonna have a debt with the bank. And how could you represent a debt in the natural number system? It's going to be a little bit complicated to represent your statement using just natural numbers because you're gonna have like two different magnitudes. But if we include negative numbers, you can have a new expression, and this is the new number set that we call the integers. So the integers will be just all the counting numbers with the zero and the opposites. And maybe you can tell, okay, we solved the problem. That's it. We just need the integers to all our problems. Now with the integers, we can apply any addition, any subtraction, and we can multiply integers between each other to have another integer. We just need to remember the rules to multiply signs. But then in comes the division. And with division, we have a problem. In division, we can divide two integers in a way that one is multiple of the other to have another integer. So for example, 3 over 1 is going to give us 3. 10 divided 5 is going to give us 2. So if we have multiples, we can divide them. But what happens when they are not multiples? Like, for example, 3 and 2. Or 3 divided 2. So then we have the new system that is required to get into divisions. In this system, this is the system that we call the rational numbers. Okay, and a rational number is any number, so let's say that it's x, such as x could be expressed as the fraction or the division of two numbers, in which a and b belongs to the integers. So if we can express any number as the ratio, that's why it's called rationals, of the ratio or the division of two numbers, of two integers, we can say that we have a rational number. There is only one little problem. It's that the division between 0, it's not properly defined. So as it's not properly defined, we need to tell that b, our denominator, should be different than 0. So it is straightforward that any fraction is a rational number. And maybe you know that any decimal, any finite decimal could be expressed, because decimals are only notation of divisions by 10 or fractions with 10. So you can know that any finite decimal could be expressed in terms of two integers. So any finite decimal is also a rational number. But what happens when you have this type of decimals that we call repeating decimals, or this decimal? That we call repeating decimals. We notate the repeating decimals with a bar over the periodic number. What can we do with these numbers? Could we demonstrate whether these numbers are rational or not? Do we need another set different from rationals to express repeating decimals? So I think that this is something we're going to learn in the next video, in which I'm going to explain you what happened to repeating decimals, and we're going to see whether repeating decimals are part of the rational number system. See you soon. I hope that you enjoyed this video. I hope that you have an excellent day, and watch me in YouTube, subscribe, and give me like. Bye bye.